All right, here we go. So this one's coming in by popular demand, guys. A lot of you kept asking, what does this symbol mean? Cosine of -1. So before we get started, the way you read this as either inverse cosine or you read it as arc cosine. They are both the same. They mean the same thing. I usually tend to say inverse cosine, but if you say arc cosine, it's the same. And basically what it means is this. Cosine, so what does that mean? So it means cosine of some angle equals a half. That's what it means. So obviously there's an infinitely many answers to this. There is a unit circle that's going to be coming up pretty soon. We'll see when we hit it up. So on the unit circle, we have this angle here. At that angle, you have this coordinate, which is a half, comma, square root of 3 over 2. Remember that cosine on the unit circle is the x coordinate. And it also happens right here at this one, where you have a half, comma, negative square root of 3 over 2. So this angle here, do you guys remember what that is? Perfect. 60 degrees, which is the same thing as pi over 3. And this angle here in blue, do you remember what that one is? What's that one? Yeah, it's 300 degrees. What is it in radians, since you gave me the radian one last time? Yeah, 5 pi over 3. Oh, yeah. So if I take my calculator, and that's, well, by the way, we're going to be heavy in the calculator usage. So here's my calculator. I hope you guys are having a good day, guys. It's a beautiful morning. It's going to be cold tomorrow. I'm excited. I'm going to be at Starbucks at 6 a.m. getting ready for my hot drink. These are good times. It's a good time to be alive. All right. So here I am in radian mode. Let me go to degree mode because I think it's a little easier to explain in degree mode. So check it out. If I type in cosine of 60, I do in fact get 0.5, the 1/2, right? If I type cosine of 300, I do in fact get 0.5. Are you guys ready for the conundrum? Here's the conundrum. If I tell my calculator inverse cosine of 0.5, which you know is these two answers here, the calculator will only give me one of them. It does not matter how many times I push inverse cosine of 0.5. The calculator will always tell me 60 degrees. It will never give me the 300. So what is the hack, or how do I do it to tell the calculator to give me the other answers? Here is the reason. Here's the hack. It's not a real hack. Do you guys see this ray here in green? And you guys told me that that was 300 degrees. Do you guys agree that if I count clockwise from the x-axis, that is a negative 60 degrees? Now notice, I want you guys to notice, if I type in cosine of negative 60, I do in fact get that 0.5. So it's not a hack, but we're calling it a hack. So here's the hack. In order for you to get to 300 degrees, or for the calculator to give you that, you got to go plus minus arc cosine of a half, and you go plus 360n. Where and if I say x equals, I can write x equals. So the very first one, I'm going to say x1 is going to be the positive one, arc cosine of a half, plus 360n. That's just going to give you the 60 degrees. And then the second one, the negative arc cosine of a half, that will give you the 300 one. Chavez, I don't know what you're talking about. Here's what I'm talking about. I'm going to type in, well, there it is. I'll clear it again. Second arc cosine, 0.5. You see how it gives me 60? So I would write it like this. I would write x equals plus minus 60 degrees plus 360n. And then x1 is just going to be x equals the 60 degrees plus 360n. And then x2 would be the negative 60 plus 360n. And check it out. Negative 60 plus 360 will in fact be 300. 300, sorry if I didn't say it properly. Does that make sense to you guys? All right, now I don't want you guys to be robots, but here is that definition that we just said. Arc cosine, put a plus minus in front of the arc cosine or inverse cosine, and there it is. If you're in radian mode, instead of 360, what are you going to write? 2 pi n, where n is an integer. N really just means how many times you've done a revolution. If you put 2 pi, notice this in black, bam, that's 2 pi, because I just did a whole revolution. So if I keep adding 2 pi to it, I'm still in the same, that's still the same terminal rate. Is this making sense to you guys? Okay. How do we feel? Do we feel amazing? Because we are, guys. You guys are amazing. All right. So don't be a robot. There's the reason why there's a plus minus in the front. Okay. Here we go. Put your calculators back in radian mode if you put it in degree mode. What we're going to do, mode radian. Second quick. It works the same with radians, guys. Look at this. Find the first 5 positive values. We're going to do 2 of them. This is example 1. And then we're going to call that example 1A. And I'm going to make an example 1B. I didn't do that before, but that's fine. So here we go. X equals plus minus arc cosine of 0.5 is the same thing as a half plus 2 pi n. And it wants the first 5 positive values of arc cosine 0.5. So on the unit circle, which is the first radian, you told me earlier, that I hit 0.5 for cosine? Perfect. Pi over 3 is my first answer. Because it says first 5 positive. The next answer is going to be, do you guys remember the next answer? 5 pi over 3. Now, I know what you're saying. Chavez, didn't you just say plus minus? Check it out, guys. Don't write this down. Just listen. If you want to write it down afterwards, you can. I'll give you time. Look at this part. I could have done this. I could have said plus minus pi over 3 plus 2 pi n. X equals, right? And then I could have gone x1 is obviously pi over 3 plus 2 pi n. No big deal there. X2 is negative pi over 3 plus 2 pi n. Here's where the awesomeness comes in. That denominator is a 3. I could have multiplied this by 3 over 3, so that turns to 6 pi over 3. Notice 6 over 3 is 2 pi. And look at this. Negative 1 plus 6 is 5 pi. Do you guys see that? All right, I'll give you guys 30 seconds to write that if you want to write it down. How it's related. Do we see it, Lavelle? Isn't this cool stuff? Math life, man. Heck yeah. What is the next one that's going to be the next one after this? Well, to find the next one, I just got to keep adding 2 pi. Don't add 2 pi to the 5 pi over 3. Add 2 pi to the pi over 3. So add 2 pi. Add 2 pi. If I add 2 pi to pi over 3, that's like 6 pi over 3. 6 plus 1? Everyone at the same time. Yeah, 7 pi over 3. Yeah, 6 plus 1, unless I made a mistake. Nope, 6 plus 1. So how do I get the next one? Add 2 pi to the 5 pi over 3. Add 2 pi. So let's see, 6 plus 5? 11 pi over 3. How many do I have? 1, 2, 3, 4? Okay. If I want the next one, add 2 pi to the 7 pi over 3. Add 2 pi. So 6 plus 7. 13 pi over 3. And yawning, that's the demerit. All right, let's do example 1B. Let's do it in blue. If you have different colored pencils, this is a good one to do example 1B. Find first 5 positive for arc cos 0.62. Okay, 0.6. No, 0.62. I already wrote it. All right. Is that a perfect coordinate? It is not. So this one you're going to go plus minus inverse cosine of 0.62 plus 2 pi n. I'm going to take my calculator. I'm just going to put x equals. I'm going to take my calculator and I'm going to do this. It's in radian mode. It says radian. I'm going to go second arc cosine 0.62. I'm going to push enter. And there I get an answer 0.902. So there it is. I'm going to write 0.902 plus 2 pi n. So here are my solutions. Ready? And I'm going to go slow. My first answer is this positive one, 0.902. So I'm going to write 0.902. My second answer is the negative 0.902 plus 2 pi. So how do I do that? I take my calculator, I put a negative, and then I scroll up, and I push enter. See? Negative that. That's a perfect answer. Plus 2 pi. And I push enter. And there it is, 5.381. 5.381, comma. The next answer comes from the 0.902. Add 2 pi to that. So I'm going to take 0.902. Chav, how do I do that? Like this. Scroll up until you hit 0.902. Push enter and then put plus 2 pi. Enter. 7.185. 7.185, comma. The next one's going to come from the 5.381. So go to 5.381. I'm going to scroll up. I'm going to push enter. Plus 2 pi. Enter again. 11.664. 11.664, comma. The final answer comes from the 7.185 plus 2 pi. So I'm going to scroll up. Excuse me. Enter. Plus 2 pi. And push enter. And there it is. 13.468. 13.468. 1, 2, 3, 4, 5. How do we feel? All right. We feel okay over here, guys? Unreal? We're good? We're good? Okay. All right, guys. We're doing the same thing. We're going to go slow or, medium speed because now we got some experience. And then I'm going to show you guys something that's going to be super cool that if you don't know how to do it this way. Okay, it says find the first 5 positive values of arc cosine negative 0.3. So immediately I go x equals, I'm going to go back to red because I like the red color. X equals plus minus, and I put inverse cosine. They mean the same thing, but I'm just putting my definition already. 0.3 plus 2 pi n. And I'm going to go ahead and write my numbers just like we did right now. So I take my calculator, and I'm going to clear everything here, and I'm going to push second arc cosine negative 0.3. The negative is right next to the enter button. Enter. 1.875. So I'm going to write plus minus 1.875 plus 2 pi n. So here are my answers. X equals, the first one is a positive one, 1.875, comma. The next answer, take the negative and add 2 pi. So what do? I put a negative symbol, I scroll up, I push enter, and I'm going to go plus 2 pi. And I push enter again. 4.408. 4.408, comma. Now to get the next number, I go back to 1.875 and add 2 pi. So here I go. I scroll up. Enter. Plus 2 pi. And then I push enter again. 8.159. 8.159, comma. To get the next one, I go to the 4.408 and add 2 pi. 4.408 plus 2 pi, enter, and 10.691. 10.691. 1, 2, 3, 4, one more. Go to the 8.159 and add 2 pi. 8.159 and plus 2 pi. 14.442. Okay. What we did is algebraic. It's one of the simpler algebraic ones. How do we feel? All right. Let's say you don't like that method. Let's say, Chav, I hate it. It disgusts me. Okay, well, hopefully it doesn't disgust you. But let's say you just don't like it. Like, I don't like it. Remember what this means. This means cosine of some angle equals negative 0.3. Now, hopefully you weren't cheated from this method because of the pandemic when you were in algebra class. You could have done this, guys. You could have typed this into y1 and typed this into y2 if you have a TI-84. If you have it inspired, then you would type it into f of 1x and then f of 2x, and then see where they what? Intersect. So check it out. Check it out. I'm going to get the same answers. If I go here, I'm going to push y equals, And I have some stuff there from the last class. I should have cleared it, my bad. Here we go. I'm going to type in cosine x into y1. Into y2, I'm going to type in negative 0.3. It was negative 0.3, right? Okay, I'm going to click on window. Don't push graph yet. I'm going to go x min 0. I'm going to go x max 6 pi, because this is going to give me 6 answers here. Y min, yeah, negative 2 is fine, or negative 1.5, because the cosine goes between negative 1 and 1. Y max, I'm going to say 0.5. And here, we're going to push graph, and look at this. Mine does it real fast because it's on a computer, but yours is going to go a little slower. Those right here, those intersections, better be those same answers. So look how I do it, guys, so you can see it right now. Yeah, it better be the same answer. Second, and then in the calculator, there's a button called calculate, because it can calculate stuff. This is for the graph right up here. So you push second calculate, and then these are the stuff. These are the actions that the calculator can do. Is there one that says intersect? Okay, I'll check right now what's up with yours. Push 5. I'm going to push, it says first curve, that blue one, yes. Second curve, that red one, yes. Those are the only 2 curves I have. When it says guess, there's so many intersections. Really what it should say is which one. So guess, go to the one that you want. And then push enter. And it should say the word intersection. And look, it says intersection. Do I have 1.875 as one of my answers? Yeah, let's do it again. Second calculate, number 5. And this time you can just push enter 2 times real quick. Bam, bam. Guess, go to the second one that you want. And then push enter again. Boom, 4.408. You see how we did it, guys? And we do it again. Second calculate, number 5. Enter, enter. Scroll to the third one. And boop, 8.159. Cool, right? Or not cool? Let's see what oh, yeah. This is the minus sign. That one. All right, guys. You guys get the picture, right? All right, so let's go back to this. We got it right. Let's go to this one. So this is actually the question I just deleted a little while ago. It says solve with a calculator this problem. That's what we're going to do, exactly what we just showed right now. I'm going to type this right here into y1. We're all going to do this together. And I'm going to type this one into y2. So let's do that. Take my calculator. Click on y equals. What was the equation? Okay, I already forgot it. 7 cosine over 13, right? Okay, to get the little fraction feature, push alpha, y equals, and then push enter. See, you get the little fraction. 2 pi over 13. And then move to the right. Close, close. Plus 9. Okay, everyone should have a y1 that looks like that. If your y1 does not look like that, please let your partner know or let me know, and we'll type it in together. On y2, what am I going to type in? 5. 5. Okay, here we go. I haven't done anything yet. Don't push graph. Push window. It wants me, look what this paper says. This means x is a subset between negative 7 and 27. All it's saying is that the domain is between negative 7 and 27. So for x min, what do you think I'm going to put? Negative 7. For x max, what do you think I'm going to put? 27. X scale, that's fine. You can go by 1 or by 5. It doesn't matter the x scale. The y min, well, I intersect at 5. If you want to see, let's see what the amplitude is. 9 plus 7. So the maximum is 16 and the minimum is 9 minus 7, 7, 8, 9, 2. So I'm going to go between 0 and 20. So I'm going to go between 0 and 20 to see the whole wave. And I'm going to push y scale by 1. That's fine. Push graph. There's my whole wave. Yours will probably take a little slower to graph. Or we'll probably graph a little slower, sorry. And I want every single one of those intersections. So let's help me out. What do I push? Second calculate, number 5. And then it says first curve, the blue one, yes. Second curve, the red one, yes. Yes, go to the one you want first. I want the left one first. I'll push enter, and it needs to say the word intersection. Negative 4.492, is that what you guys got? Perfect. X equals negative 4.492, comma. Now get the other one. I'm going to do it again. Second, calculate number 5, enter, enter, and then scroll over the second one and push enter. Negative 0.508. Negative 0.508, comma. Now I'm going to go to the next one. Second, calculate number 5, enter, enter, and then scroll to the third one, and then make sure it says the word intersection. Enter. Does it say the word intersection? Yes. 8.508. Go to the next one. Second, calculate number 5, enter, enter, scroll to the fourth. 12.492. Go to the next one. Second, calculate number 5, enter, enter. We got 2 more. 21.508. And one last one. Second, calculate number 5, enter, enter. 25.492. How do we feel? Now I want you guys to enjoy how the beauty of math. Look at this, guys. Let's see if we can notice something. That's my b, right? The b is 2 pi over 13. And remember we said that we calculate the b by doing 2 pi over period. So that means, according to this, the period is 13. So check it out. Is the difference between 8.508 and 21.508, is that difference plus 13? It is. Is the difference between negative 0.508 and 12.492, is that difference plus 13? It is. It repeats every 13 degrees. So if you look at it, if you're looking at this graph, the difference between this one right here, and I'll get out the way right now. The difference between this one right here and this one right here, that's a 13-degree gap because it repeats every 13. The difference between this one and this one, that's a 13-degree gap because it happens every 13. It's a sinusoid. No, it's gonna be perfect. It's not gonna be. It's not gonna say 13.0000. It's gonna. If you take these decimals and subtract them, it's gonna be a perfect. That's the resolution is off. Okay, see how it says first curve? And it's see the word intersection. First curve, enter, second curve, enter. Now it says yes, we're hovering over it. Intersection, 25.494. It's going to be perfect. Which is what I got here. See? So what word do you need to see, Lettuce? Perfect. How do we feel? All right, check it out, guys. We're about to do something awesome. We're going to get these numbers, but we're going to do it algebraically. Isn't that exciting? Yeah, no, it's going to be so cool. So now it says this. Find algebraically the 6 values of x in example 3. But it says the word algebraically, so that means we're going to compute them. We're going to calculate them by hand. Almost. We're going to need the assistance of a calculator, obviously. But we're going to show you the step-by-step. So the first thing you do, write that statement. So help me out, and let's write that statement together, guys. Write 7 cosine 2 pi over 13, x minus 4, close, plus 9 equals 5. All right, so let's see if we know what the goal is. I want to solve for x. So the first thing I got to do, I have something here plus something here. equals 5. So I need to get rid of that 9 first. How do I get rid of that 9? Subtract. So subtract the 9, and you're going to have now 7 cosine 2 pi over 13, x minus 4, close, equals 5 minus 9 is negative 4. Does everyone know where that negative 4 came from? Okay, I subtracted the 9. Next, I have 7 times cosine. I need to get rid of that 7. I do that by doing what? Divide by 7. So now my next line is going to look like this. Cosine 2 pi over 13. That's a 2 pi there, guys. Parenthesis x minus 4, close, equals negative 4/7. So catch up to there. All right, next, I need to get rid of the word cosine. It's cosine of all this stuff. It's called an argument. So the only way to get rid of a cosine is to do it starts with the letter I, the inverse. So let's do the inverse. So then I'm going to write my next line is going to be 2 pi over 13, x minus 4, equals, and I'm going to put plus minus. I'm going to do my definition. Plus minus arc cosine or inverse cosine of negative 4/7 plus 2 pi n. Because it repeats every 2 pi. Well, obviously we know the real period, but that's the general form for the parent function, cosine. Are we still okay, guys? All right, next, I need to get rid of the 2 pi over 13. And yes, you can say if you want, divide by 2 pi over 13, but usually when you have a fraction, you multiply by the reciprocal to get rid of it. So we're going to say multiply it by 13 over 2 pi. Whatever you do to one side, you got to do to the other. 13 over 2 pi like that. So when I write my next line, here's how you're going to write it. You're going to write x minus 4 equals, that 13 over 2 pi goes right here, and it goes, bam, right there. So you're going to write plus minus 13 over 2 pi, arc cosine or inverse cosine of negative 4/7, close it, plus, when you distribute that 13 over 2 pi to the other term, the 2 pi n, the 2 pi's cancel out, and you get a 13n. Do you guys see that? And that's actually how you can check if you're doing this right. The period is 13, so that 13n is how often this repeats itself over and over. Does that make sense, guys? Okay, the last thing you got to do is move the 4 right in front of the plus minus, plus 4. So put it right in front of it. So x equals, this is called a general equation, 4 plus minus 13 over 2 pi, arc cosine or inverse cosine, negative 4/7 plus 13n. Are we okay, guys? All right, here we go. I'm going to split this up into 2 equations. I'm going to write x1 equals, and I'm going to do the 4 plus 13 over 2 pi in my calculator. So here is my calculator, and I'm going to go, bless you, second quit. I'm going to clear this so I can have less space there. 4 plus alpha y equals, to get the little fraction, with it 13 over 2 pi? 13 over 2 pi. And then move to the right. Arc cosine with a negative 4/7. Okay, just run it to there. Do not put plus 13n. Just to there. Push enter. I got 8.508. Is that what you guys got? Okay, so I'm going to write x1 is 8.508 plus 13n. x2, instead of doing plus, I'm going to do a minus. So you don't have to type it in again. Just scroll up. Look, push the up cursor. Push it twice. Push enter. And then move the left cursor. I'll hover over the plus sign. And then change the plus to a minus. Push enter. And there it is. Negative 0.508. So I'm going to write negative 0.508. Negative 0.508 plus 13n. I want you to notice that 8.508 was one of our answers. Look at that, right there. And when I add 13, I got the other answers. I want you to notice that negative 0.508 was this one right here. Isn't that cool? So let's find our answers with this, guys. So I'm going to write x equals. I'm going to leave some space because I can see that I'm missing one. The very first one I hit from these two is the negative 0.508, comma. The next one that I hit from those two is the positive one, 8.508, comma. The next one comes from the negative 0.508 plus 13. So I go to my calculator. I'm going to scroll up. I already have it right there, negative 0.508. Push enter, and then go plus 13. Enter. 12.492. So 12.492, comma. The next one comes from the 8.508 plus 13. So I take my calculator. I scroll up to the 8.508. Push enter. Plus 13. 21.508. Comma. The next one comes from the 12.492. So go to the 12.492 and add 13 of that. 25.492. And I think that's the last one in there. Okay, well, the last almost. I'm missing one. How do I get this leftmost one? Subtracted from which one? From the 8.508. So I'm going to go to the 8.508. 8.508, where are you at? Way up there? Okay, there it is. Enter. And I'm going to go minus 13 this time. And there it is. Negative 4.492. Negative 4.492. Which was, yep, there it is. And we got them all, guys. And now look at all that math that you just did. So scroll out and admire your beauty. Isn't this almost like art? Doesn't it look beautiful? Like, would you be scared if you were a 6th grader doing that? But not anymore. You guys are beasts now. Isn't that cool? I think it's cool. I don't know. I like it, guys. All right, we're getting started. Hopefully, once we accomplish this, then we can go into real life scenarios like predicting high tide and how many sunspot cycles and when's the pendulum going to be at a certain location and weather patterns and temperatures. It's going to be cool, guys, because all those are sinusoids by nature. All right, sorry, I got excited there. All right, so we just